So this video is on the oxidizing ability of the halogens. And there's only one aim for this video really, and that's to know and explain the trend in oxidizing ability of the halogens. That's group 7 elements. So in order to know the trend in oxidizing ability of the halogens, we have to look at a few reactions first. Now we haven't done these in class because they're pretty boring, to be honest. But if we look at them close up, then I can commentate over them. So we're going to be adding together the halogens to their respective salts. So we're going to be adding chlorine to sodium bromide, sodium iodide, bromine, sodium chloride, sodium iodide, and iodine, sodium bromide, sodium iodide. We're not going to be adding the chlorine, sodium chloride, or bromine, sodium bromide, and iodine for sodium iodide, because what we're looking for is the evidence of a displacement reaction. And the displacement reaction won't happen between these ones because there's no point in them displacing each other, if you like, because chlorine is not going to displace chlorine, because they're going to be the same reactivity. So the first one we're looking at is sodium bromide plus chlorine water. And when the chlorine water is added, you can see there's a discoloration of the sodium bromide, and so that means a reaction is happening. So if you look at the before and after pictures, which will come up in a second, you can see there's clearly a discoloration, and that's the bromine coming out there, being displaced. So we can say there is a reaction there. Now we're looking at chlorine water plus sodium iodide. And again, you can see clearly there's discoloration. That's iodine coming out of the sodium iodide and chlorine replacing it. So you can see there is a reaction between chlorine and sodium iodide. So if we look at the before and after, you can see that there's clearly a reaction has occurred, a displacement reaction has occurred. So next one is bromine water plus sodium chloride. So here's the bromine water, and we're adding, the sodium chloride, we're adding bromine water. You can see there's no change in colour. And so here there's not a displacement reaction happening. And again, if we look at the before and after pictures, in a second, you can see there's nothing happening there. And so bromine added to sodium chloride, there is no reaction. Bromine water plus sodium iodide, however, when we add bromine water to sodium iodide, you can see that there is a discoloration happening. You can see that it's going more red, if you like, and so a displacement reaction is occurring. You see as we add more and more, it's going blacker and blacker, and that's the iodine coming out. And so the reaction between bromine and sodium iodide does have a reaction. And you can see that there's a difference in the colours before and after. So if we have iodine and sodium chloride, so that's these two reacting together, you can see there's no discoloration happening, there's nothing happening that would show that a reaction is happening, so there's no displacement reaction happening there. And again, we'll see the before and after pictures. You can see there's no difference before and after, so there's no reaction between iodine and sodium chloride. And finally, iodine and sodium bromide. Again, you can see there's no discoloration as you add the iodine to the sodium bromide, so again, there's no reaction happening. If I just make this a little bit clearer by adding some colour, you can see there was a reaction between sodium bromide and chlorine, sodium iodide and chlorine, and sodium iodide and bromine, but there wasn't a reaction between sodium chloride and bromine, and sodium chloride and iodine, and sodium bromide and iodine. So if we just have a closer look at what is happening in the reactions that did occur, I'm just going to number them. This one number 1, this one number 2, and number 3 for this one. I'm going to just discuss what is actually happening in those reactions. So for the first one, we've got chlorine reacting with sodium bromide. And what that made, you could see a discoloration, which was the bromine coming out of the sodium bromide, and then the chlorine replaced or displaced the bromine, and so sodium chloride was made. To balance that, we need 2 sodium bromides and 2 sodium chlorides. Now actually, the sodium bromide originally and the sodium chloride that was made were both dissolved in water. And so these two things are ionic compounds, and those ions are going to be separated from each other in solution. That means that we've got sodium plus ions floating around on the reactant side and sodium plus ions floating around on the product side. And we call those spectator ions because they're not actually doing anything in the reaction. And what an exam will often ask you for is the Ionic equation for a reaction, and that's just an equation which only shows the ions and the elements that are reacting. So in this case, we'd have chlorine reacting with 2 Br-. We won't write the sodiums because they're not reacting, they're just spectating the reaction, if you like. And what that made was Br2 plus 2 chloride ions. Again, we ignore the sodiums because, again, they were just spectating in the reaction. So that would be the Ionic equation, and the full equation would be this top one here. For the second reaction, sodium iodide with chlorine, a similar thing was happening again. So we had chlorine reacting with 2 sodium iodides to make iodine, which was that black stuff that came out, plus 2 sodium chlorides. And again, the Ionic equation would be Cl2 plus 2I-, again ignoring the sodium, goes to make I2 plus 2Cl-. What this Ionic equation also shows you is that it doesn't matter what this other ion is. That could also be a potassium, it could be a lithium, it could be any group 1 metal or group 2 metal for that matter. And then this third reaction was Br2 reacting with 2 NaBr, going to make, sorry, not 2 NaBr, it's 2 NaI. Just correct that. Two NaI goes to make I2 plus 2 NaBr. Again, you could write an Ionic equation for that, and you can do that yourselves if you wish. So from these reactions we can see that clearly as you go up the group, the halogens become more reactive in that they oxidize other things more easily. And the reason for that is down to the number of electron shells they have. So as we go up the group, the oxidizing ability increases. And to explain this, we have to think about what is actually happening to the chlorine, the bromine, the iodine when they oxidize something else. And what's happening is they're getting reduced themselves. And if you remember oil rig, if something's being reduced, it is gaining electrons. So the question is, why does it become easier to gain electrons as you go up this group? And the reason is that the number of shells decrease. And in doing that, the electrons would rather go on an element that has less shells because it can get closer to the nucleus, there's less electron shielding. So to explain this, you'd say that the halogen is being reduced itself when it's oxidizing something else, and it becomes easier to gain electrons up the group, which is what is happening when it's being reduced, as there are less electron shells. And so less electron shielding. I hope that all makes sense. Please make sure you email me if you don't understand any of the things that have come up in this video.